Number 18, the position of a particle moving along an x-axis is given by x equal to 12t squared minus 2t to the third, where x is in meters and t is in seconds. Determine the position, the velocity, and the acceleration of the particle at t equal to 3 seconds. Letter D, what is the maximum positive coordinate reached by the particle? And letter E, at what time it is reached. Letter F, what is the maximum positive velocity reached by the particle? Letter G, at what time it is reached. Letter H, what is the acceleration of the particle at the instant the particle is not moving, other than at t equal to 0. Letter I, determine the average velocity of the particle between t equals to 0 and t equals to 3 seconds. Okay, so for letter A, we want the position when t is equal to 3 seconds. So we have to find x of 3. So we just have to replace the letter t by the value that we want, which is 3. So it would be 12 times 3 to the 3 squared minus 2 times 3 to the third. And this gives us 54 meters. So that's the answer of letter A. For letter B, we want the velocity. However, we don't have the function of the velocity, but we can find the function of the velocity by taking the derivative of the position in function of time. So that would be the derivative of 12t squared minus 2t to the third in function of time. And this is equal to 24t minus 6t squared. So the velocity in function of time is equal to 24t minus 6t squared. And we want to find the velocity when the clock shows us 3 seconds. So again, you just have to replace t by 3. So this is equal to 18 meters per second. Don't forget to include the unit. So that's the answer of letter B. For letter C, we want to find the acceleration. However, we don't have the function of the acceleration, so we have to find it. And we find it by taking the derivative of the velocity in function of time. So we're taking the derivative of this function over here, which is 24t minus 6t squared dt, and this is equal to 24 minus 12t. And so this is the function of acceleration, 24 minus 12t. And in letter C, we want to find the acceleration for t equal to 3 seconds. So it would be 24 minus 12t. Sorry, we have to replace t by 3. And this is equal to minus 12 meters per second squared. So that's the answer of letter C. Letter D. What is the maximum positive coordinate reached by the particle and when it is reached? So we want to find the maximum value of x. And we know that the maximum value of x happens when the velocity is equal to 0. So what we're going to do here, we're just replacing v by 0. We're going to find t, and then we are going to use this t in this function over here. Let me write this function over here. X of t is equal to 12t squared minus 2t to the third. Okay, so let's say that v is 0. So 0 is equal to 24t minus 6t squared. So one of the answers is t equal to 0. Let's call it t1. So you can see that if you replace t by 0, you would have the answer. The second answer is t. Let's solve this equation. Okay, so 0 equals to 24t minus 6t squared. So you can cross out 1t if this is squared over here. So 6t is equal to 24. That means that t is equal to 4 seconds. Okay, so let's call it t2 and that's t1. So which one is the correct one? Let's see. We just have to replace in this function over here. So the first one is x of 0, which is 0, of course, 0 meters. And the second one is x of 4, which is equal to 12 times 4 squared minus 2 times 4 to the third. And this gives us, let's see, this gives us 64, if I'm not mistaken. Let's do 64 meters. Okay, so that's the answer of letter D. For letter E, we want to find when the disposition happens, and we already done that. It happens at t equal to 4 seconds. So that's the answer of letter E. Letter F, what is the maximum positive velocity reached by the particle? So we're going to do in an analogous way as we have done for letter D and E. So for letter F, we want the maximum value of v, and the maximum value of v is reached when the acceleration is 0. So we want that the acceleration is 0. So we want that 24 minus 12t should be 0, and of course this is t equal to 2 seconds, right? So t is equal to 2 seconds. And then we have to replace 2 in this equation over here. So v of 2 is equal to 24 times 2 minus 6 times 2 squared. Sorry, times 2 squared. So, and this gives us, let's see, this is 48 minus 24, and this gives us 24 meters per second. So that's the answer of letter F. Letter H, letter G. Letter G, when that happens, so at what time it is reached. So we already have done that, so it is t equal to 2 seconds. So that's the answer of letter G. Letter H, what is the acceleration of the particle at the instant that the particle is not moving? So the particle is not moving when v is equal to 0, right? So when the velocity is 0, the particle is not moving. We know that. So when the velocity is 0, let's see, we have already done that. So v is 0 when t is equal to 0 or t is equal to 4 seconds. However, we want other than t equal to 0, so we want t to be equal to 4 seconds. And we want to find the acceleration when t is equal to 4. So the acceleration when t is equal to 4 is equal to 24 minus 12 times 4, and this gives us minus 24 meters per second squared, right? That's it. So that's the answer of letter H. For letter I, determine the average velocity of the particle between t equal to 0 and t equal to 3 seconds. So the average velocity is equal to delta x over delta t, which is equal to x of 3 minus x of 0 divided by 3 minus 0. So x of 3 we already calculated over here, so it is 54. X of 0, it's 0, right? So just replace t by 0 over 3 minus 0, and this gives us 18 meters per second. So this is the answer of letter I, and that's it.